Hello, hi, good afternoon. Welcome to Tech Party. My name is Owusu Dusai Kofi, founder and CEO of Soko Aerial Robotics. I am your guest speaker for today, and I'll be talking about autonomous mission planning for survey professionals. First of all, I would like to thank the organizers for this wonderful event, and I hope we all can learn for the sake of science. Thank you for your time. In this presentation, I'm going to use a simulator to explain it to you. And just because you don't have access to the real device, the good thing about this simulator is that its output is very similar to the exact drone. And on your screens, you have the basic factors that we consider when it comes to autonomous flight planning. First, you need to consider the height at which you want to fly, the overlaps, and also the terrain that you want to fly. In our party today, we're going to use a fixed wing to try to take off and fly an autonomous mission. And the basic idea when it comes to using fixed wings to take off involves we setting up a few parameters. And as I said, every takeoff requires some bit of information. So in our case, we are using a fixed wing that requires a runway. So we need to have an acceleration on the ground. And then once we take off, we then navigate to the various waypoints. And in setting up this acceleration, we will fly it manually. And then once we take off, we will switch the aircraft into an autonomous mode for the aircraft to continue flying. Now, once it reaches that height, the next thing we have to do is to navigate the aircraft to the various waypoints of interest whilst capturing our image. And finally, a few characteristics regarding how we're going to apply some simple principles like overlaps and side overlaps. And the next is how we're going to plan our approach landing. We're not going to go into so much details. It's basically about how to plan and execute an autonomous mission using a fixed wing UAV that uses a runway. So let me quickly switch to my simulator and let's get started. So my aircraft is ready. I'm going to go to my plan side and then quickly plan for my mission. So this is where my aircraft is. It's at the very start of the runway, and I'm going to set my takeoff parameters. So I start with my initial flight height. So I want to do about 30 meters. Sorry. And then I'm going to pitch it at 15 degrees. So that's where my takeoff is. Let's assume that that's where my takeoff point is, and then I have my first waypoint. That's waypoint 2. That is like approximately 100 meters away. From the takeoff point. Yeah, so that's pretty decent for us to have any transitional change into the mission area. And I'm going to select my area of interest by using the polygon tool. So let's assume we want to map the airport residential area. It's a bit modernized, and the local authorities want to see the extent of development that is happening within this area, and to use the data to prepare anything. It could be revenue mobilization, urban growth monitoring, even developmental changes. And we're going to fly from Kotoka International Airport and then map out this area. So as I said, this is a basic simulation. Now, I'm sure it's a decent size. It's not that big, but for the sake of time, let me reduce it a little bit so that it doesn't take too much time. Yeah. So let me input my waypoint. So I'm gonna go with survey grid, and let's see what we have. So yeah, and this is my survey grid. So I have some interesting statistics about my flight. So I have a flight time of around 43 minutes 20 seconds. I'm taking close to 674 images, and I'm covering a distance of 24.96 kilometers. Okay, that's not bad. Let's increase our height to somewhere around 250 meters, which I think is a decent height. So we have a reduced in flight time about 20 minutes, and we doing about 8 strips, and we now have a reduction in terms of number of images. And with the camera that we have, we're going to use a Sony RX 100 MK3, which is about 20 megapixel camera, and it's going to give us a very decent ground sampling distance, which is around 6.85 centimeter per pixel. So that is like the smallest pixel we're going to get at a very depth zoom in. So let's look at that. The area has a ground elevation between 380 to 64 meters. So, I mean, literally, there's no way the aircraft is going to meet any obstacle around this area. Our best bet is aircraft, but then we are working in a very coordinated environment, so we're able to sense the environment and make sure that the drone is safe and does not interfere with our airport's manned aircraft systems. The next thing, so here we have the camera details. So this is the image width as well as the image height, the sensor size in terms of the sensor width and the sensor height, and this gives us the various field of views for the horizontal and the vertical. And we also have the grade option. So here we have the distance between the lines. That's basically the distance between this and that. We also have the overshoots. So the overshoots are when the aircraft is making the turn into the next waypoint. How far should it overshoot in terms of making that turn into the new strip? And here we're going to start from the home point. We're keeping a decent overlap, which is around 70% for the forward and 70% for the side overlap, because it's an urban environment and there's a lot of dissimilar features, so we will not have so much challenges in terms of image processing. And at the same time, we still want to make sure that we have decent features in the image and also have easy access to how to align the images. And then yeah, we flying at a speed of 27 meter per hour. So yeah, and this is our angle of approach. We could actually change this value depending on how the wind is actually coming in on our area of interest, because for a fixed wing we always have to fly into the wind so that it will help the aircraft without burning so much fuel. So once that is done, we accept it, and so I have my mission grid made ready. So my aircraft is going to fly these paths, and then once it's done, it's going to come back home. Now, the interesting thing here is that I need to clear my polygon, sorry, and then plan for my approach in terms of how I want to land. And you could see that I cannot come this way and land like that. It's not a multi-copter, a quad system. The landing has to be a sequential system. So I'm gonna assume, or I'm gonna try and come from this side of the runway and then do a decent approach. So let's say once it's done mapping, it goes through this way, and then it turns in into the airstrip, and then it starts making a decent approach, coming in, and it's coming in hot, and then it finally lands at the home point. Yeah. Now we need to actually make sure that we engage a very decent landing sequence, and the basic principle is to focus for the four main landing approach. So starting from, so I count from the bottom, 1 2 3 4, and then I initiate the landing sequence from the fourth stage. So that's I do land starts, and then from there I start to reduce the flight height. Yeah. So from 250 to 100, and then after the do land start, it dropped to a very decent height. I don't want to move that like change very abruptly and burn so much power. So yeah, and then my final height is 0. And the most important thing is to make sure you maintain a decent dive angle. So let me put this one a little bit back. Yeah. So let's see. Good. I mean, is this just for simulation? Yeah. And so yeah. Let's see. Yep. So yeah. So 1 2 3 4. Yeah. We good. So now the next thing we have to do is to upload the mission onto the aircraft. So I write the mission onto the aircraft, and off it goes. And now do a few pre-flight checks. So here, and also make sure I take off in the right mode. And I cannot take off in this mode because this is not a quad plane, it's a fixed wing. So I have to switch to fly by wire, which is like a manual mode where I'm going to take off manually, and then once it's airborne I switch it to auto. So I go to action, I need to do a pre-flight calibration of the air pressure sensor on board the system, so I do that, and then once that is done, I arm the system. I have a little GPS issues, and this is, since this is a simulation, we can ignore it, but on the real world you cannot ignore it. You have to make sure that you solve this problem before you fly the system. So I'm gonna push my throttle and then engage my takeoff. I'm airborne. Now once I'm airborne to a decent height, I switch the system to auto mode, and then it takes over. That is brilliant. So you can see that the flight path is being followed, and here the waypoint navigation information is being showed up on my message taskbar, and the aircraft is airborne. This is beautiful. So it started taking the images, and you can see here and it's still doing a decent climb. Don't forget the flight height was around 250 meters. So once it gets to that stage, it will keep still and keep flying that constant height. You can see the speed is kind of normalizing, and then yeah. So one strip is done, is making a very decent turn into the next strip, and that is beautiful. So one will ask why the need for this, and I will say that it gives the pilot a lot of experience, a lot of planning time, and a lot of trial and errors in terms of practicing your takeoff and landing sequence. And of course, it's a simulation environment, but it builds your knowledge base in terms of how to keep practicing, how to keep flying safely, and how to improve your skill set. So there are no communication issues, there are no GPS issues, but even if there are issues of such nature, I have programmed the aircraft to engage in safety procedures, which is return to home about the mission, and then I could figure out what the problem is and get back on board. So in your screens, we are just tracking the plane. And as I said, on the field, you don't need to keep your eyes off the aircraft. You always have to keep your eyes on the aircraft, which is both physically, visually observing it in the air and also monitoring it on the ground in terms of its telemetry behavior on the ground control station. So we have how many strips to go? We have about 4 more. It's on the third one. Hmm. So that is the next strip is done. It's gonna turn. Okay. So A few lines to go. We have about 68% battery left. Let's see. So pretty moving fast enough. Yeah, that's good. Let's go. So the last two, and then we are done. It's keeping a very decent height, fluctuating between 249 250. Yeah. Yeah. So if you have any questions, you can just send it to my email address, and then I would answer you. If I cannot answer, I would let you know too. So there's the last waypoint, sorry, second to the last waypoint. Yeah, we losing our RC. Let's see. I'm sure it will regain connection. Oh, okay. Yeah, we've regained connection. Yeah, that's great. That's great. That's great. Uh, you can see that the terrain is a bit interesting. We have quite a good number of high-rise buildings, and this is causing a lot of issues. Yeah, that's nice. Then we are left with the last strip to complete the mission. We still have some decent power, which is about 59%. Yeah, which I think is very good. So, yeah, let's see. Okay. Interesting. Uh, yeah. So let's see. We're done with the last waypoint. Yeah. And there it comes home. Yes. So it's going to start the landing sequence. So you can see that the height is dropping. Yes, that's a decent deceleration. It's coming in hot here. Yeah, so it's going to waypoint 44, and then from there it goes to the other waypoint. Yeah, and it's dropping bit by bit, but in a very nice and smooth. We have a decent ground speed and as well as air speed. Oh, we're having RC issues. I hope it regains. Let's see. Yeah. Okay. Yeah. We've regained connection. Then it hits the. So we just passed over the Ghana Civil Aviation Training School. Yeah. Pretty tight. Yeah. So let's see. heading to waypoint 45 and then make that beautiful turn towards Spintex direction, and then it comes in. And I have always loved looking at those huge airliners coming in from that direction, and it's beautiful when you are around the underbridge and then you could actually see uh, the ties hanging in there and then coming down. It's very beautiful. Yeah, and it banks in, and you can see it has started a landing sequence. Yeah, which is on your screens there, and it is coming in hot. Okay, let's see. Let's zoom in a little bit, else we still monitor it here. Okay, it's dropping, it's dropping, it's dropping, and we coming, we coming, we coming. Nice one, nice, nice. This is beautiful. I mean, this visualization for training is beautiful, and wow. So it just got to the next waypoint, which is 47. Yeah, here we go. So we should be expecting it anytime soon, coming in. Yeah, flying over quickly. Yes, should see it. 42 meters away. I should be seeing it coming from somewhere here. Yeah. It may overrun the runway a little bit, but yes. So that is our last waypoint, and yeah. Okay, it overshoot our runway, but I just want to see it. Yeah, yeah, it is. Yeah, yeah, coming in beautifully, 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 slowly, slowly, and then I will land it. Disarm. Okay, thank you for watching, and if you have any questions you can send them to sokoaerial@gmail.com. I really appreciate it.